Hello everyone, this is Dr. Joy Datta, and today I am going to present our research paper entitled Advanced eHealth with Explainable AI, secured by blockchain with AI empowered block sensitivity for adaptive authentication. And my co-authors are Dr. Hussein VLD and Tudako. Dr. Hussein is currently associated with University of Cambridge, UK, and Dr. Tu is associated with NTNU, Norway. Let us first introduce the problem that we are trying to solve in this particular research paper. As you know, in today's world, there are rapid deployment of IoT and cloud for the advancements of the EL is already happening, and integration with IoMT and its computing in this particular e-health domain is making a big change. In today's world, adoption of AI in any field is a natural thing. And in a similar way, in healthcare, adoption of AI is actually in its initial phase. Here, when we are trying to apply AI in the healthcare, the most important question or the important question that comes to anyone's mind that why is the transparency? Because AI will be predicting something, and based on that, we'll be taking certain decisions, and that decisions will impact actually human life. So if there is no transparency in the decision, so people will not accept the suggestion that is given by the AI. So that is one of the major issue when we are trying to adapt AI in the healthcare. Also, another thing, how to secure the data that is collected using different healthcare application. So security is one of the very important feature that is very much required whenever we are considering about healthcare. So the questions we need to think about healthcare is like in healthcare, whether all the data will have similar kind of importance. Is it so or is it not? So from our understanding, we know that whenever data is collected in healthcare, so based on the patient's condition, based on different kind of scenarios, whether the person is in hospital or in a lab where he's doing or she's doing testing, or normal day-to-day life, who is actually checking different healthcare vitals. So in different kind of scenarios, different kind of data will be coming. Even if someone is in a hospital, there are also the vitals that will be collected from that person using different IoT devices that will have different kind of importance based on the readings of the data. So think about a person who is in ICU. If the person's condition is critical, so data is of very high importance. So based on different vitals, doctor might decide to give different kind of medicine. So uh, we need to understand that data will have different kind of importance in different times. Okay, so this is one thing that we have to keep in mind while applying any security mechanism that is applying to the data. But presently, whatever the solution in healthcare is present, so they're applying same solution. That means, so if it is securing data in a with a certain protocol, so it is applying that particular algorithm or particular protocol, particular security mechanism uniformly. But the thing is, when we think about we'll be looking for the data, so we know that the data will have different kind of importance at different times. So when the data is critical, we can go for another kind of solutions and like more secure approach. When the data is normal, like vitals are normal, we can go with normal approach. It don't require that kind of security protocol. So why we're trying to say so? Because if we go for different protocols has different implications. So in terms of energy conservation, in terms of cost, so there are different aspects to it. So that's why, since all the healthcare data is not of equal importance, we can think of a solution where a resource utilization based solution could be one of the best approach. And how the resource will be utilized based on the sensitivity of the data. That is how sensitive the data is based on that. So in terms of securing data, blockchain-based solution is one of the proven and tested solution. So that is one of the solution approach that we can follow that is already proven. But another thing is like when you're thinking about the different kinds of data, different sensitivity of the data. So how to make those classification that which data is how much sensitive. So this kind of work is new in this particular field. So it is not explored. So this is where we are trying to focus here. So what we can say here? So the clear research gap that we can see that lack of adaptive authentication mechanism on data sensitivity in blockchain-based healthcare system. So everyone till date, whatever the solution that is there, they're providing similar solution, same solution to all the data, where the data itself, when we're collecting from the patient, so it is not of having similar importance. So this is where we can focus. And second is, because of this first point, the inefficient resource utilization is the second concern. So we can utilize the resource more maturely than whatever the other mechanisms are doing without hampering the security strength of the overall mechanism. Thus, our problem statement is traditional security protocols lack adaptive measures in block data sensitivity identification, leading to inefficient resource utilization, necessitating a secure eHealth framework that leverages blockchain and explainable AI for adaptive authentication based on data sensitivity. To achieve the same, we have proposed IoT-edge-cloud based framework for future eHealth. Here we have integrated artificial intelligence, explainable AI, and blockchain for advanced features that we want to see in this particular framework. So now our proposed framework looks something like this. So here there is a patient database where we have two kinds of databases. One database is cloud-based, where we are storing electronic health records of the patients. It's a historical database. The other one is edge-based database, where IoT-based data is getting collected and getting stored. So this data is getting pre-processed, and finally we are getting the model-ready data. Is a pre-processed data. So by utilizing this data set, our AI model is predicting what should be the outcome. And the explainable AI based model is actually explaining why the AI model is predicting something like this, whatever the prediction it may be. And the counterfactual explanation, this part, is actually suggesting how you can inverse that particular prediction. So if it's predicting that your heart attack chances are high, or like say 90% chances that you can have heart attack. So how you can minimize these chances? What are the things that you can do? You can control. So based on the controllable parameters, what are the remedial actions you can take? So that is given by this counterfactual explanations part. And the medical experts actually reviewing all this whole setup and giving suggestion based on this. So this feedback is coming back to the pre-processed data set. Here, one thing to keep in mind, to make the whole process secure, here the data is getting stored in a blockchain, both in the cloud and as well as in the edge. And we're thinking that this solution could be consortium blockchain. So it's a kind of private blockchain where multiple entities, say like a hospital chain, can access your data or something like this. So the objectives here are to develop secure eHealth framework by leveraging consortium blockchain and explainable AI. Here also we have the motive to use artificial intelligence to understand the block data sensitivity and use that particular sensitivity concept, block data sensitivity concept, to make the authentication adaptive. Further, our objective includes increase the transparency with the help of explainable AI and make the system more secure by integrating blockchain. And finally, we also want to evaluate this framework in a cloud computing environment. Now, to understand how blockchain and explainable AI is integrated in this particular framework, we need to understand how these two concepts are integrated, particularly in this particular architecture. So in terms of blockchain integration, we're actually integrating a consortium blockchain that is making the storage secure. Along with this, the heart of the blockchain, what is making this blockchain secure is the consensus. Here we have used the proof of authentication PoAh consensus mechanism to make this particular application suitable for IoT or IoT-based scenarios. Along with all this, we have also implemented the role-based access control system, which is a necessity to realize a eHealth scenario. Further, to make the whole system transparent, we have incorporated explainable AI, where along with our AI model, we have integrated explainable AI model SHAP, which is giving us the explanation for AI model's prediction. Along with all this, we have also used counterfactual explanations with the help of DICE model, and we have also used medical experts to validate what are the prediction that is coming here in this model. How the whole framework works? In this particular context, the data is collected from the IoT-based devices and electronic health records. Then, real-time insights we're getting. Okay, we're getting the real-time insights from the edge, and finally, this insights along with the data it is getting stored in the blockchain at the edge. Now, if you think about the block level, what is happening, where actually AI-driven security is coming to the picture. So when a data is coming and it is forming a block, so first AI is actually understanding what is the sensitivity level of the block. That means what kind of data is there inside a block. A block is nothing but a group of transactions. And what are the transactions here? It is nothing but some healthcare records. So if the sensitivity level of the transactions are higher, say out of 100 transactions, if more than 20%, 30%, 40%, based on the different scenarios, we can give that number. So if more number of transactions are sensitive, so we can say the whole block's data is sensitive, and we can put a number with this sensitivity level. Okay, and this sensitivity level we can put in the block header. So adaptive security level we can put based on the block data sensitivity. If the sensitivity level is 0, that means normal. If the sensitivity is 1, that means it is a little bit sensitive. And if the sensitivity level is 2, so it's a highly sensitive data. And these sensitivity levels are actually defined by the random forest model, which we have tested and validated throughout the process. In terms of adaptive authentication, what are the steps we are following? First step is obviously collecting the data from different IoT-based devices. Then, with the help of AI model, we are determining the block data sensitivity. That means a particular block is holding which kind of medical data. Based on our understanding, here in this particular case, we make the data set like 0, 1, 2, like normal data, sensitive data, or critical data, something like this. And based on this sensitivity level, we are actually applying here adaptive authentication mechanism. And here, as I have mentioned earlier, we have followed the proof of authentication mechanism as a consensus to make this blockchain thing applied in the real world. Finally, the concept was to update the metadata part of the blockchain. That means we are trying to update the metadata part, that means the sensitivity part in the blockchain's metadata, such that without looking at the transaction data, anyone can understand that what is the sensitivity level of the block. Finally, where we can implement the adaptive security and then do the validation and testing. In our experimental setup, IOMT-based synthetic cardiac arrest dataset was used in our study. We have also used Raspberry Pi 4 for processing the AI algorithms. In the block structure that we have used here, there we have header portion, a data portion, also other information. So these are the three main portions were there. In the training data, we have 27,000 blocks. In the testing data, we have 4,000 blocks. And overall, we found that the random forest accuracy in the source data set, it could be classified with the help of random forest with 99.2% accuracy. So the initial data set that we have taken, that itself is highly accurate and can classify it as, like, in terms of hard prediction, very high accuracy. With very high accuracy, you can predict. So if we see, or if we look at the confusion matrix of the random forest classifier, here you can see with the level 0, level 1, and level 2, you can see the support values are actually very high, and very few values, these numbers are there, which is actually classified wrongly. Further, we have seen different features, importance while prediction. So if prediction is something coming as 0, so hard prediction 0 means hard will not happen, or hard prediction 1. So what are the importance of different features like bioimpedance, or like a person is walking, what was the speed, or like SpO2 value, there is the oxygen level in the blood, okay, or where they are taking the data, whether it's house or in ICU or in a normal hospital. So this kind of things, this kind of information also matters. So what is the importance of these values? Okay, these feature values that is depicted in this particular picture. Further, along with random forest, we have also tested the cat boost model, which is the categorical boosting based model. We have trained this particular data set with both random forest and cat boost model, and we have seen the training time of the cat boost model is comparatively higher. But what we have seen, the prediction time is actually very, very less for cat boost. And also, you need to keep in mind here is a random forest and cat boost when we are actually using some training data. So training data we are training once. It's not like we're training all the time. So once training is done, we are using it for the prediction. And the main data set could be like we can make the data set larger and larger as the time goes, but the prediction time is the main thing that matters. And we have seen cat boost model is actually performing very well. And one good thing about cat boost model is, as you will be considering more and more features, cat boost model generally will perform better and better. So instead of 5, 6 feature values that we are considering here, in real life cases, when we'll be going with 30, 35, or 40 feature values, cat boost model will perform better than most of the other models. Because the design of the cat boost model is something like this. The more categorical data it will have, so the more perfect this model will be. So we can summarize the result as follows. So actually here we have utilized on IoT-based synthetic cardiac arrest dataset, and we have used this dataset for secure blockchain transactions in EL. By utilizing this particular dataset, we have achieved a high accuracy of 99.83% with the help of random forest, and even with tenfold cross validation also we are getting similar kind of accuracy. In terms of effectiveness, there are very minimal misclassifications are there in terms of confusion matrix analysis. And the key takeaway in this research will be cat boost model is preferred when we need rapid prediction, and in terms of real world scenario where number of features will be more. In that kind of scenario, cat boost model will outperform random forest. Though random forest and cat boost models performance are similar when handling this kind of data set, which is not that much big in terms of TB or GB. Okay, so we're handling only few hundred MB data set. So if it is going to GB or TB, and also the number of features when it is becoming more like more and more complex, like 50, 60, 70, more number of features we're considering. So cat boost model will be obviously outperforming random forest. So that is one trade-off that we make here, and come up with a decision that in small, if the dataset size is small, number of features are small, we can go with the random forest. If the dataset size is big as well as number of features that is the real world, if you think about the real world cases, it's a complex dataset. So cat boost model will outperform. And by utilizing this concept, actually, we can say that we can identify block data sensitivity pretty accurately. And based on this sensitivity identification, proper sensitivity identification, we can apply appropriate security mechanism to make adaptive blockchain-based consensus work. Okay, so this is the first step of the research work, where we can say that yes, we can identify the sensitivity of the block pretty accurately. And since we can identify the sensitivity of the block, further, based on the sensitivity identification, when we are going for adaptive authentication, that thing also can be done pretty accurately. So that is our next research that will be doing adaptive authentication based on this sensitivity. So thank you, everyone. If you have any question, please feel free to ask me, or you can send your queries to this mail ID. Thank you, everyone. Have a nice day. If you have any question, please feel free to ask.